In this video series, we're going to talk about object-oriented design. Now, what do I mean by object-oriented design? Well, let's think about the trajectory that we took when we were learning about functions. In the beginning, we taught you how to call functions, either functions that were built in or provided for you already. Then we taught you how to define functions, how to write a function definition, and what happens when that function definition was called or executed. Oh, but that was really just sort of technical, sort of describing what the code should do. That's different than what we talked about in the algorithms lesson, where we taught you how to design functions. When we talk about designing functions, we mean going from this English specification of what the function should do and figuring out how to write the code that meets that specification. Now, when we've been teaching you about classes, we've been mirroring the same process. In the beginning, we taught you how to instantiate a class, how to create an object for a class that was provided for you already. Then, we taught you how to write a class definition, the syntax and details on how do we add class attributes and how we add methods to the class definition, and also what happens when we create an object for the class or call a method on an object of that class. But once again, this is really just technical details. What we really want to do is we want to teach you how to design a class. The idea is that I have some English description about what that class should do, and you should write the code, completing the class definition that meets the requirements of this description. Now, when we talk about object-oriented design, we often break it up into interface and implementation. When we talk about interface, we mean how the code fits together. So if I have multiple programmers working on a class, how their code fits together so they can both work on the class together. Or if I have an application, applications are often made up of multiple classes, how do those classes fit together in order to make the application? Now, if we think about what happened when we were talking about functions, when we had multiple programmers, the way that we coordinated them was with the specification, right? The specification was this formal contract that allowed them to work together. And the same is going to be true for classes. It's just that in the case of classes, there isn't one specification. There's the class specification, right? That lists the attributes and its invariants. And every single method, there's probably more than one, is going to have its own specification as well. The interface is all of these, not just one specification. Okay, so that's the interface. What is the implementation? Well, the implementation is what the code does. What happens when you create an object for the class, and what happens when you call a method on an object of that class. And this is essentially defined by the code in the methods of the class definition. So when we talk about interface and implementation, it's the same idea that we had with functions. We're giving you an interface, and you're going to be writing the implementation that carries out that interface. To make this completely clear, let's just go look at an example. Here we have, inside of Atom Editor, I have this definition of a class called time. And if I look at this definition, well, okay, first, if I look at the specification, it represents times of the day. I have a class specification here. And in this class specification, I list my attributes, which are hour and minute. And I have my invariants, such as hour is between 0 and 23, and minute is between 0 and 59. I have some additional methods here. I have an initializer. And as you can see in the initializer, it has its own parameters and preconditions. I have another method that allows me to increment the time or move it into the future. I have some other additional methods. In fact, one of these methods right here that allows me to test if it's the afternoon or later. Now, all of these doc strings here, you'll notice we have the doc string for the class specification, we have the doc string for the method specification. All of these things together are the interface, not just one of them. The implementation, well, that's the code for all of the methods. So if I look at this, I have some code that's implementing the initializer. Here I have a code that is implementing the method that increments it. And here I have one line of code that implements this method to test whether or not it is the afternoon or not. The implementation is all of these. It is not just the implementation of one method. So, as we've said, what we're going to be doing in this course is exactly what we did with functions. The idea is that I'm going to give you an interface, a collection of specifications, and you're going to write the implementation, all of the code for all of the method definitions for the entire class. Now, it might seem that this is pretty much exactly the same thing as writing definitions for functions. And for the most part, that's true. However, we have to be careful because, as we've said, the interface is multiple specifications, and these specifications interact with one another. When I write a method definition, yes, I need to meet the specification of that method, and therefore I need to make sure that I'm dealing with all of the preconditions and that all of my code is going to satisfy what is written inside of that specification. But I also need to make sure that I don't violate the invariance or do anything that is not permitted by the class specification. So the way in which the class specification fits together with the method specifications is what we're going to be talking about in this video series.